Hello, listeners, and welcome to the sixth episode of the Adapt podcast, the podcast about how society adapts to the world's growing challenges. My name is Harish Murgason, and I am a present senior at Dublin Durham High School in Dublin, Ohio. Now, today I am honored to be joined by Dr. Zolton Kemeny. Dr. Zolton Kemeny is a renowned inventor and multidisciplinary engineer with 200 plus patents in his name. He has also obtained a PhD in structural engineering, architecture, and economics at Budapest University. Currently, Dr. Kemeny is the CEO and president of Global Air Cylinder Wheels, a company revolutionizing wheels with their air suspension wheel, also known as the ASW. Thank you again for joining me here today.
You're very welcome.
So before I like to talk about the products and the innovations, I always like to ask the big leaders in each field on what are some of the steps that got you to the place you are at today, and essentially what is your story?
Well, I don't know about big leaders. We are a small company, but we will be big, hopefully, for sure. So-called unicorns, whatever, based on the potential, the demand in the industry, and the reception. The world's largest mining companies are courting us and then ordering, but we still finish the final testing before we go large scale production. And that will happen the end of this year or early next year. The story is that I was driving in Germany on a autobahn, and then I saw a truck tire on fire and see the destruction all around. And I thought that must be a better way. So I thought of the problem, and I thought that it should not be the tire itself, because that can be punctured. Just that alone is very dangerous. But also when it gets on fire, and then I researched it, and I saw that in the mining industry, the mines, a tire fire is very frequent and very dangerous. The driver is sitting up on a 5-story high truck, and then he has to climb down on a ladder if the tire gets on fire, but he has no time. So he has to jump in a tube canvas to parachute to get down. Sometimes they break the leg, but at least alive, because the entire truck is on fire, is instantaneous. So then, and many people die from that. So then I said, well, this must be solved. Also, the puncture. When one tire blows up in a mine, that makes a big crater in the hole. It's like in a war zone, and it kills people all around. It happens, unfortunately, every mine in every year. So then the tires, which I figured out, I said there is enough space in the tire space to put suspension in it, just like the car has suspension. The mining trucks has no suspension, only the tire itself is flexibility. So I put design inside the space pneumatic suspension with hydraulic dampers. So just engineer the system, which will be the same flexible as a rubber tire, but will never explode because it's full metallic. So you can hit with rocks, and then it runs forever. A rubber tire in the mine lasts only for half a year, and it costs $100,000. So it's a very big expense. And then once I redesign this, then it will last as long as the truck itself, which is 15 to 20 years, not half a year. Of course, you still have to replace the outer shell, but piece by piece, bolt it on. So it has very good features and good in demand. So no more tire fire and no more puncture. And it's also the only wheel in the whole world which can save fuel. All others consume just waste fuel. You have to overcome rolling resistance, and this one reduces rolling resistance by 30%. So therefore, the leadership I don't know about, but I know about the great potential, the big demands we have with this one. Of course, it works not only in mining, it works for trucking and military and forestry, agriculture, construction, and other wheels. Even on small one, my first wheel was a wheelchair. I built into the wheelchair. So but it will be so soft, springy when you come out from hospital, then you don't have to worry about a rough ride. And also bicycles, tricycles, other big markets. So there are several verticals. We are just concentrating to the largest one today. These wheels are 14 feet diameters, 15 tons, so extremely large. It's like a big house, one wheel. Each truck needs 6. So these are big business, cost a lot to make it, to tie it, prototype it, and it's a lengthy process. The mining operates in 5 years terms, so we have to explain to investors that this is a business in which we have to be patient. But nevertheless, the rewards are extremely large. So that's my short answer. Probably you expected an even shorter one.
No, it works perfectly fine. I was actually curious though on when you mentioned about how the wheels kind of create lots of like fire hazards. So I think from like a normal, just everyday kind of like car driver, the idea of like wheels catching fire doesn't really make sense to me. So how and why is this hazard so prominent in, these large mining machines and agricultural machines?
In the highway, you seldom see it. It happens, but not as frequently as in mines. In the mines, just from sparks, friction, whatever, the main and most frequent contributor is lightning. I did not think of myself because I said lightning is so rare as well. No. For instance, Western Australia, it happens every day, many times. So the entire mine operation has to stop, sometimes for days or weeks, because just one hit will kill the driver, everyone around it. And it happened. I did not see my personally one, but when I arrived in 1 mile, they said that last month one worker was killed and the driver hospitalized, anyone who is nearby. So lightning does it. So also think about coal mines. When some fire happens, then the entire field can light up. So there are firefighters around. So the fire is only just one reason, because you ask how it came about. That was the idea came about. But after all, I found many other problems with the tire. The tire is, some people, environmentalists, say it's a dirty because the biggest polluter. And then you have to discard, and then it doesn't dissolve in 100 years. So that in mines, tires are so big that you cannot even take out, so they have to bury in the mine site. It's like the first 10 miles when you drive in a mile inside this tire cemetery. So then it's a big problem, but also a big problem because even on the highways, these are micro polluters. It's the carbon black in a tire that makes it black color. It works against the ultraviolet light. That is burst, and then you just can't get rid of it for 100 years or even more. So that problem is solved. So this is an absolutely green product because it's 100% recyclable. Metallic, you just melt it back and make tires. And that you cannot do with rubber tires. And there is a shortage on caoutchouc, the base material, latex of it, natural and all produced in Indonesia, politically unstable environment, and then prices are going up every year enormously. So tires are expensive, and then the metal steel is relatively to that cheap, and it lasts obviously much longer. But of course, because it has moving parts, any suspension system, you have to maintain. But that mine get used to maintaining. They have maintained the truck anyway. So every year, one truck is running for 360 days, and 5 days go into a big shop where they clean it and grease it, and everything is checked and fixed, sealant, whatever it is. Same with our wheels. So it needs maintenance, which is inexpensive, but it's part of the design same way as the truck itself. So it's part of it, and therefore it lasts as long as well. So economical as well in a long term, it represents 60% savings. In a short term, more expensive because you just can build with steel, with moving uh, parts as cheap as just a thin rubber, like a balloon.
Yeah, that makes a lot of sense, and it's really cool to see how this is able to, I think, economically support uh like decrease costs and really make it more efficient that way. So when it comes to the air suspension wheel, it could, if you could you please like describe it to I think the viewers at home and just like tell me what it does in simple terms
It
and
has,
like how it works.
yes, yes. So your car has suspension system, which is usually just coil springs that provides the softness, and also has dampers because if too lively, then it's just bouncing forever. So it has to hug the road slowly. Once it's disturbed, then you have to come back slowly. The damper does it. It has, so they have uh, these two together. You see like a piston-like structure and coils around that is above each wheel suspension. And that you consider we built into the wheel all around. But instead of using these coil springs, we use air cylinders, which is a gas air spring. It's much easier to tailor for this purpose. And then the damper is a hydraulic damper. Or we just use dissipative air cylinders. And we arrange it all around. So each one, with each rotation, gets one cycle compressed, decompressed. The gas is when you compress in a piston cylinder barrel arrangement, it heats up every compression, and then every decompression, it cools down. So it's about the same heating, cooling evens out. There is a little friction between the oiled piston wall and the barrel, so that heats up slightly. The system we measured in 55 miles per hour and a dyno part that after half an hour, the pistons warmed up by 1 degree. So then practically it's a self-contained system which handles heat very well, so no heat problem. A tire has a heat problem. Mining trucks to stop every so often just to check the temperature of the tire because if it overheats, then it delaminates. So that problem is solved here. So that is just simply the same suspension what you would have otherwise, just built all around in a circular fashion inside the wheel. You won't see it because we cover it with a steel wall to protect it from rocks and other rain and weatherproofing, we call. And then otherwise, we use the absolute minimum is 3 cylinders. In a bicycle, it's possible, feasible, but in large wheels, no. We have 12 cylinders in every wheel, then 6 dampers. And then in our website, globalaircylinderwheels.com, you will see pictures moving how this works, and then you can see explained in detail for technical minded people how it looks and how it works.
That's very interesting, actually, especially how I think I've never heard of anything like the air cylinder being used in such a unique way. So that was really cool. Previously you did talk about kind of how your first prototypes was around like that wheelchair. So that got me thinking as to is there any difficulties that come from, you know, bringing to fruition such a big product as, it might be easy to make a smaller version at like on a wheelchair, for example. Is it harder to kind of scale that up in not only the engineering process, but kind of an entrepreneurial process? How difficult is it to scale it up?
So I built the wheelchair just to see, would this work ever? Just proof of concept. Is this a stupid idea or is really maybe a good one? And it worked. Then I built into a Toyota Land Cruiser and then built in a laboratory environment in Dynopad when the uh, the the vehicle is stationary, but drums are running the wheels so that you can measure scientifically what's happening. And then, and also drove in the highway a little bit without asking much permission. We didn't say what is it, just wanted to try, and that worked very well. And then I thought, now everyone will ask that, can this be scaled up like you asked? Uh, to a larger one. So I said, let's see where is the biggest problem. And then I learned that the biggest problem where the size is biggest, the tires are the largest. That's in the mine, the largest tires in the mining industry. 400 tons trucks needs 4-meter diameter, very large wheels and tires. So that I said, okay, so if I can prove it in a large one, then everyone will believe that I can make it smaller. But if I do the other way around, it may take me 10 years and they still won't believe it when I get to the mid-size truck that, okay, can you make it to an even larger one? Can you bring it to the mine? Because that's where the biggest need. So I said, we will turn around. We start with the largest, and then we go down instead of up to the smaller size. So the next one, our uh, uh, program is the trucking, because highway trucks are just as numerous, same problem. So because it saves fuel as well, about 8%. So that also will be economically very important. If you have like these electrical trucks, like we have now from Nikola and Tesla, right? Then it's very important for them not to save fuel. They don't use fuel, but to extend the range, the driving range. Instead of 100 miles, they can drive 130 miles or 120 miles. That's very important on the same charge. So then it's even more important for the electrical vehicles because those are heavier and they eat tires with good appetite. So that the tires are every electrical vehicle is more expensive for that reason. and more polluting.
Yeah, that actually that got me curious as well, because you talked about kind of like once you started from small to big, it was going to take you 10 years.
Mhm.
So, that got me thinking as to since these tires and air cylinder wheels are mostly used on mining machines, do you think there'll ever be a day where you find it more fitting for, I think, as you said, electric trucks, electric cars, and I think as we're seeing more electric cars as well, like Rivians and Teslas, do you think this can
Yeah,
eventually be shrunk down for just average everyday cars?
not only can, we have design for that. We just did not spread in 5 directions all at once. We focus on one, the mining now, and we try to far out to other companies, the rest, the other vertical, that includes these electrical vehicles. And we have the design for that. So then we are in the process of negotiating. Another one is military wheels, the tax on the tanks were replaced already a long time with four rubber tires each side. And if you see that in a battle, you will shoot first the tire, right?
Yeah.
And then the problem is solved. Not really, because they keep running, because once you shoot the tire, then they pump air constantly into it. So you save the day in the battle, but not the war itself. So then by the end of the day, you have to go to the shop. There is no shop over there. You have to fix it at field, etc. So then a steel tire, which you can shoot hundreds of bullets, but runs the same shaft as a rubber tire, would be vital in the battlefield. So we have that design as well. I hired a company who will make prototypes for that and introducing to the military. Same program we have for other industries, including construction, forestry, agriculture, and trucking as the main one. And we keep like a cherished and part of it, which we like, the bicycles and motorcycles and others, because those are very popular. Like a mountain bike, you can imagine this is a very soft, so it provides a far easier and better ride. And it looks cool because it have air cylinders, not just these spikes. So probably it will be very cool when you introduce that. But we are not there yet because we don't have enough manpower for that. But we just started, so then it will happen. Yeah.
Mhm. Yeah, I don't doubt that that the bicycles with the air cylinders, it'll definitely be a trendy cool thing in the future. I can definitely see it.
It will be, yes.
Yeah. Now, in one of my previous episodes, actually, I was talking to an innovator that created a more efficient way of saving water in the bathroom industry. And she actually
Mhm.
said a very similar point to as what you said a few minutes ago. Whereas I think it was something along the lines as kind of focusing on one thing before expanding into, many other different markets. So that kind of reminded me of, I think, that experience and what that innovator agreed with as well. So my question is there any severe difficulties that comes to when you're expanding into other fields that maybe you don't think this is the time to handle those difficulties now? So what are some of those difficulties or issues that come with expanding into other fields?
Mostly just convincing investors that invest in that particular line, because then we need to hire for that particular field specialty engineers who understand that field better than the other field, or team up with companies who are very good at that. That's what we do. Instead of hiring more people, we team up with engineering firms who has the manpower ready and the expertise, and we just extend our arms. Like instead of hiring 3 engineers, we hire a firm who has 20. And then instead of having 3, 4 years of experience, each and every one has 20. So then that is the way we approach this one. And also the way, for instance, the JP Morgan company run, the CEO explained that in military terms, the strategy that orient yourself, observe, orient, uh, analyze, make a decision, act on it, and repeat. Okay, so that means that every time you have a new situation, you solved one problem, you tried it one, but then you got in a new situation. Then you start again, and depends where the market will bring you, but study your competitors, study the market very well, study the technology, and get better every time, because you will be better as well in the process. As engineers, we are practically an engineering firm yet. But, we farm out the manufacturing and the sales to companies who are good at that. You don't have to be good at everything, but you have to have a good team or team up with good entities in that field, engineering firms and others, marketers, and then manufacturers, maintenance. Like in a mine, we need just a maintenance crew is different from the one who is assembling it, and is different one who is making it. So then all these specialized fields, you just organize them, and practically a handful of people like you just pull the strings with good contracts. And of course, we have to have good intellectual property protection. We spend about $500,000 per year just on patent protection, and we have over 100 issued patents worldwide. So then we are viable in the sense that if someone, for instance, a large company, we were approached by several that they want to buy out completely, then at least we can make a good deal with them. But that's not the purpose. We want to grow into that. We want to increase sales, pay dividend, and be a large company with contracting everywhere. Right now, we operate mostly abroad, like in South Africa, Australia, Chile, Canada, China, and but also in the US. The majority of the activities are abroad. So
Yeah, I
then
totally understand.
we spread the word.
Mhm. Yeah, I get it. That makes sense. When we're going back and looking at, I think, kind of the engineering side of what you've done, I think one of the most overlooked fields in engineering is material science. I feel first, in my personal experience, I've never seen really the recognition for material science. So, which brought me curious as to, was there any new materials? Because I know, although you said that you use a lot of metals and obviously part of the air cylinders and like plates and stuff, were there any other new materials that was needed to, I think, protect certain areas of this product or fix any specific problems?
Yes, for instance, hinge, which has moving, oscillating parts, needs special, like nylon, but we have a better product, stronger one in the line, which you are thinking. The other one is the cover, uh, like fiber reinforced Kevlar could cover instead of steel, because that is not structural. Inside, other parts are. Also, the threads which hits the road, we use polyurethane instead of steel, last longer and stronger and better and less polluting. So then we use special materials. Also, another example, the ballistic aluminum. So you would think that you shoot a bullet to a steel plate, and that is the best armor. And it turns out to be that you make the same plate aluminum 3 times lighter. Of course, it's a little more expensive, not 3 times, but more expensive. However, if you use a regular aluminum, then it will spall. It will break out a large piece of the aluminum plate. But if you use specially developed aluminum, it's called ballistic aluminum 5000 series, that means that the bullet, instead of crushing, taking out a large palm size plate, instead of that, it goes inside, it is yielding and catches the bullet. So you will see on the video that the bullet is still there. It cannot go further, but the entire part goes in. It's like a U shape and holding it. That's so amazing that you wouldn't believe that a material scientist can come up with that kind of material, but it's real and it's fascinating. And of course, we search what are the best materials for this product, and we use everywhere where we need to. So then that is the main part of our job, to find the best components, what we can buy, because we cannot reinvent the whole world. We just use best from everything and integrate, bring it to bed, test it. Once it works, okay, now deploy and make a product out of it. There is lots of sweat and work between the idea and the product on the market. And that's what we are doing, sweating and enjoying it.
Yeah, I definitely agree. And I have to also agree with the fact that material science is definitely a very interesting and fascinating field. Now, sadly, as we are running out of time, one of my favorite questions I like to ask at the very end of all my interviews is, what do you think is the next few, what is the next kind of boundary and like age, I guess, of technology and innovation in the future, as we have different things like artificial intelligence and augmented reality coming up? What do you think is that next frontier?
I I did not think about that. Of course, I'm watching these artificial intelligence, whatever. Uh, uh, Probably I would agree with Mikio, the Japanese physicist, who said that the AI is just a glorified copy machine. I think it's more than that now, but it will be far from what everyone expects to it. It's a good tool, and you can use like every tool for good purpose and for destruction. And what I see that unregulated, it goes to the wrong direction. Regulated, be even worse. So that it's a big problem. Every new technology like that, but the real things would happen in other technical fields, which is quite banal. One is like the wheel itself. I'm not quite sure that the electrification of vehicles will be sustainable. Probably the world will go back to the uh, gasoline and diesel, or a combination like a hybrid. Hybrid makes more sense until we have a breakthrough in battery technology. With so much investment, we are still not there. So therefore, it's like a political technology, which I'm not a big fan of it. But whatever is emerges in the market naturally, that's more important. So the more banal programs will come first, I believe, from in agriculture, which provides food more uh, effectively, and then the electrical, I mean, the hydroelectric project. I don't even believe in the wind, but maybe the wind under the oceans would be a better energy source. And then we could see some new development like a kite and providing so energy production in a other simple way other than burning fossil fuel. But there's nothing wrong with fossil fuel either, just that became political as well. Just in fact, the problem is mostly not with the technology, but the access to it and distribution. So it's highly political. But what is developed in the military, it always comes to the economy later, penetrates. So then keep an eye on that, whatever they develop. It's very unfair in a sense that you develop the best technology in the mind to kill someone else, but inevitable.
I totally agree with all that you said about the future and the next frontier. So sadly, this interview is coming to a close, but I just wanted to say thank you again for your time. And thank you to all the listeners listening at home. I hope you enjoyed the sixth episode of the Adapt podcast.